Welcome back to math class. This is Mrs. Witt. This is Math 7, Lesson 15.1. So it's week 15, lesson 1. We are going to be exploring equivalent expressions. Okay, to get us started, we're going to recall some terms that we already know, but I want to make sure that we're all using the same language so that we all understand what it is we're talking about. When we talk about a rational number, we remember that begins with the word ratio, right? So it's like a fraction, m over n. So it can be represented, it is a number, because we're talking about rational numbers, that it can be a fraction. It has to be able to be represented as a fraction. It could be positive. It could be negative. It could be 0. It can be a decimal as long as it is terminating or repeating. Okay. Equivalent. When we discuss something being equivalent to something else, that means it has the same value as something else. An expression is a group of characters. It's a grouping that has a specific value, right? It is things that are all brought together, grouping that has a specific value. So it doesn't just have to be numbers like 7. It can have numbers and variables. It can have operations. It can have grouping symbols in it. All of those things together, meaning that these things stuck together represent a value of something. We remember that when we distribute, that really means that we are multiplying across some grouping symbols like those parentheses. We discussed that on the lesson with the distributive property. And what are factors? Well, factors are what we multiply together. We multiply together to get a product, right? So, for example, if I said 2 times 3 equals 6, what I'm really saying is that 2 and 3 are factors of 6. I can multiply them together and get 6. Or 2 is just a factor of 6, 3 is a factor of 6, 1 is a factor of 6, 6 is a factor of 6. So it's anything that I can multiply and get to there. Now let's talk about some things that we might not be as confident in, but we've probably heard a lot of these before. So a variable, what its job is it represents an unknown value. Often we will see this as the letter X or Y or really any other letter. It can be any symbol actually, but what it is it represents something we don't know yet. A coefficient, you'll see that it is, I think, like it goes with, it goes with, it's multiplied to the variable. So it goes with that variable right in front of it generally, okay? And a constant, so it's a number by the way, and a constant, that is just a number. It's always the same. It is constant. It has a constant value, okay? So if I look at this and I say, let's use an example of 2x plus 3. Well, in 2x plus 3, 2 is that number that's being multiplied times x. It is my coefficient. X, I think we can recognize pretty easily that is our variable. It's the only one that's a letter up there, and we don't know what x means. X could be 7 or 5 or 12 or 10,000. We just don't know. It's standing in for something else. And then 3 is our constant, right? Because 3 is always 3. 3 doesn't wake up one day and decide to be 7. Okay, and when we talk about like terms, that means they share the same variable And if it's a like term, it shares the same variable, we can conclude that an unlike term does not share the same variable. All right, so those are all very important keywords that we're going to be using throughout the coming weeks, and I want you to become very comfortable with them. So let's review the distributive property for just a second. This is something that we've tested on it already, we've explored it. I think that we're pretty confident in it, but just to remember, the distributive property means that I can take this A and I can multiply it across to the B, and I can multiply it across to the C. Whatever I do to one, I have to do to the other, and that will get me A times B and A times C, right? Good. So let's consider this. Let's just start thinking here. If I have 2 apples plus 3 apples, well, what do I really have? Well, what I really have is, let's see, these 2 apples I could represent right here. And these 3 apples could be represented right here. And if I were to ask, well, what does that mean? How many apples altogether are there? Well, 2 of the apples plus 3 of the apples, we could count them. 1, 2, 3, 4, 5. We can see that that gives us 5 apples. And apples in this instance is just an example of what a variable does. So here, if over on the right I looked and I said, well, I've got 2x plus 3x. Well, I could represent that as x plus x plus x plus x plus x, right? And where did I get that from? This is my 2 x's right here. These are 3 x's. And altogether, how many x's do I have? Well, I have 2 of them, and 3 of them, I have 5 x's. So what I've done there is I've taken my 2 terms that both have an x, so they share an x, they both share that same variable. They are like terms, right? They both have an x. So I can combine them to make 5x. Pretty simple, but what happens when things change a little bit? So I've got my 2 apples and my 3 apples, but now I've also got 3 bananas. Can I just have an apple nana? Well, I cannot just have an apple nana. Okay, let's see what this is. This is representing those 2 apples there. Here's my 3 apples for that. And then my bananas. I have a banana and a banana and a banana. Okay, so I can't just all of a sudden turn these into apple nanas. Can't do that. That's not okay. But I can gather up all of my like terms. So here I've got 1, 2, 3, 4, 5 apples. And I've got 1, 2, 3 bananas. And I can list them next to each other. And that still simplifies my statement from the left that I have 5 apples plus 3 bananas. And that is essentially what I would be doing if I tried to combine unlike terms, right? They don't have the same variable, so I can't just, combine them willy-nilly. I have to list them separately. So here I have x plus x, that's my 2x. To that I'm going to add 3 x's, 1, 2, 3. But now I've also got 3 y's, 1, 2, 3. So what I can do is I can combine these things that are the same, 1, 2, 3, 4, 5 x's, and I can't make those x, y's because they're different, but I can list them just next to it. And then I can say plus 3 y's. So you can see that the apples and the bananas, the x's and the y's, we don't have to get confused when we start seeing letters in math. They're just symbols that represent a value we don't understand yet, or that we don't know yet. And when we're combining them, we can always combine things that are the same, but we can't combine things that aren't. So let's go ahead and write that down so that it's very important we remember that. We can combine like terms. And remember back from the very beginning, like terms, that just means they have the same variable. But we cannot combine unlike terms, or terms that have different variables, we can't add those together. And pay very close attention to signs when you're distributing and combining like terms. So by that I mean the positives and the negatives. We have to make sure that we're following all those rules that we have talked about in the past. So let's practice a little bit together. And if you're doing this on Edpuzzle, I'm going to pause and give you a few minutes to work on this on your own. All right, so hopefully you've had a minute to look at the first two, and you've hopefully answered the Edpuzzle questions, but I know I can take that 4, and I've got 4 times x and 4 times positive 2. So what I can do is I can take, I'm going to write it out the long way for right now so that you see it. I've got 4 times x, and I'm going to add to that, I have a positive 4 times 2. So what is 4 times x? Well, we can just write that as 4x. And what is 4 times 2? That is just 8. Well, now we can't put the 4x and the 8 together because one of them has an x and the other one doesn't. So this is as combined and as simplified as we can get it. Let's look at the next one. 2 times a positive 2x and then a positive 2 times a positive 5. Well, again, let's do it together. We've got 2 times 2x, and we're going to add to that, because it's positive, 2 times 5. Well, 2 times 2x, that really, let's kind of imagine that for a second. Let's explore that. What does 2 times 2x mean? Well, that just means there's 2 of the 2x's. So there's a 2x here, and there's a 2x here. Well, how many 2x's are there? There's 2 2x's. So I've got 2x and 2x, that gives me 4x. So I could have looked at that as, over here I've got x plus x, and over here I've got x plus x, and all together I have 4x's. Or I could have looked at it that just 2 times 2 is 4, and I keep that x. Okay, so that's just kind of an aside to think about how do we do that and what that really means. I think that we all already knew, but just to be sure, sometimes it's good to break it down. All right, let's get back to where we were. So 2 times 2x is 4x. And then I've got 2 times 5. Positive 2 times positive 5 gives me a positive 10. And I can't put my 4x and my 10 together. They don't have the same variable. They are not like terms. Okay, I'm going to pause for a minute. Actually, no, I'm going to work through it with you. And let's work through this first one together. This first one and the next row together, because it's a little bit different. And hopefully you can see how it's different. But I'm going to do the same thing. I'm going to take my 3 times my x. And this time I've got something different here. This isn't a plus, this is a minus. Well, what I want you to get in the habit of doing is putting that, I want you to get in the habit of putting whatever sign that is in front of it with that very next number. So I want you to think about this as a positive 3 times a positive x, and then a positive 3 times a negative 7. That's how I want you to look at that. Okay? Now let's start again. So we've got, and you don't have to write it all the way out every time. You can write 3 times x, and now I've got a positive 3 times a negative 7. So I've got a positive 3 times a negative 7. So 3 times x is just 3x, and then positive 3 times negative 7, well, a positive and a negative make a negative, and a 3 times 7 makes a 21. And I can't combine my 3x and my 21 together because they don't have they are not like terms. So this becomes a minus. So a lot of people just look at this when they're first starting. They say, well, there's a minus in the middle, so I'm going to keep a minus in the middle in the answer. And that works sometimes, but I want you to really be cautious of that is really taking it times a negative 7. Now you try the next one. All right, so I've got a positive 5 times a 2x, and then I've got a positive 5 times a negative 3. 5 times 2x, so that means there's 5 copies of 2x. Altogether there are 10 x's, because that's 5 times 2. Then I've got a positive 5 and a negative 3. When I multiply those, a positive and a negative gives me a negative. 5 times 3 gives me 15. I cannot combine 10x and negative 15 because they are not like terms. And now if you look at this last one, this last row, well, I've got my plus back in the middle, but this time I want you to notice that this number out front is negative. Well, that's not really going to change anything as long as we remember our rules, okay? So what I have, my first one is negative 2 times x, and then I have a negative 2 times a positive 8. So negative 2 times x is negative 2x. Negative 2 times positive 8, well, a negative and a positive gives me a negative. 2 times 8 gives me 16. I can't combine those because they are not like terms. There we go. Now you can do the last one. Okay, and on this one, I notice I've got negative 4 times 2x, so I've got negative 8x. But here, I've got a negative 4 times a negative 4. Well, a negative and a negative become positive, and a 4 times a 4 gives me 16. Again, I cannot put those together anymore because they're two terms that are not common. They do not have like terms. So that should give you enough information to get started. I do want you to understand that what we've done in all of these with distributing is that we have created equivalent expressions, okay? So remember those expressions, those are groupings of things together that have a specific value. So let me just make sure that we understand this. So let's take that first one as an example. I had 4 times x plus 2, right? I'm going to just take this first one. 4 times x plus 2. Well, my next step gave me 4 times x plus 4 times 2. And I could do that in my head. The longer I've done this, the more used to it I can get, the more I can probably kind of take a shortcut there. But then I finally ended up with 4x plus 8. And what I want you to recognize, why I put these equal signs in between these, is that each one of these is equivalent to the one before. So I can distribute across those parentheses, but I can't change the value because they are equivalent expressions. One way to test that is we could just pick some test number and stick it in there. Let's say that x was equal to 1. If we said, let me move that out of the way. Let's just say that if we said x is equal to 1, then if I put 1 in for any of these x's, each thing that is separated by an equal sign should have the same value. So let's try that. Let's try 4 times, let's see, instead of x, we'll write 1 plus 2. And we're saying that that's the same thing as 4 times, instead of x, I'll put a 1. And down here, same thing. My x, we're gonna just pretend it's a 1. So now let's simplify some things here. Let's see. 1 plus 2 is 3, right? And 4 times 3 is 12, okay? Well, here, 4 times 1 is 4, and 4 times 2 is 8. That is 12. Here, 4 times 1 is 4, plus 8, which is 12. So if you see, each one of these is an equivalent expression because they all, in this case, if x were 1, they would all equal 12. And if I picked any number to put in there, if I said that x was equal to 7,000, they would still all equal the same thing. They would all have the same value. That is because they are equivalent expressions. And if you question whether something is equivalent and it's really just kind of twisting your head up and you're not sure how that works, just pick a number and stick it in there and see if it holds. All right, so with that, you should have enough to get started on your practice.